Since the introduction of aggregates on the platform, SQL nodes haven't been used that much, and that is fine. After all, aggregates account for 80 to 90% of the development skills. However, this doesn't mean that we should forget about SQL nodes. So today, I'm going to bring you three different items, three different things to up your SQL skills using the platform. My name is Barbosa, and I'm a developer advocate at OutSystems. So before I start, let me give you a little bit of context about this demo that I have prepared for you today. So I have a database, okay? It's a simple, ordinary order line database. So I've got my orders, I've got my order lines, I've got my departments, my products, and so on and so forth. This is mostly one-to-many relationship. So we've got one order with many order lines, one department with many products, one product with many order lines. And just to get a little bit more context, I have about 40 departments, I've got 4,000 orders, 40,000 order lines, and about 400 products, of which 100 of those never sold, and you'll see in a moment why I am talking about that. So the first thing that I want to discuss with you is that situation where we have a fairly simple aggregate, and we are wondering if we should or not use a SQL node instead. Let's take a look at this aggregate, and we'll see that I am joining products, actually a left join of products and order lines, and then I join products with departments. What I'm trying to find out here is products that have never sold, okay? Products that do not have an entry on the order line. And the way that I can determine if this is actually a good query or a bad query, or if I'm going to get in trouble with this query in the future, is that I actually have to look and understand what the database server is doing. In this case, we are using Microsoft SQL database on the backend. So we need to use the proper tools to identify what are the execution plans, how is the database server actually going to solve this query. So what I can do is I can look in here and copy the query and use it directly on the SQL server. Okay, so I am going to first format this query a little bit better, okay? So I like to use the Pure SQL formatter, which is a very cool tool. So I just paste an ugly SQL query on this, and outputs it comes with a nice formatted SQL query out of the box. So I'm going to copy this, and I'm going to do new query in my Microsoft SQL management tool, paste this, and as you can see, the query executes perfectly well. Now, in order to really analyze this query, I am going to remove some stuff that I don't need. We have to remember that aggregates have that optimization, so they will not retrieve every attributes of the tables, right? So they will only retrieve the ones that are actually being used. But here on the SQL side, when I just paste this query, I can see everything. So I'm just going to remove the things that I don't care about. I want the ID, the department, the order line. I don't need anything from the order, so I can just get rid of this. And I need the ID, the product, the department of the product, and the unit price. I actually don't even need this one over here. I just need the product department, right? Now, another thing that I always do here is that I include a hint to the SQL server so that as I modify the query, right, I'm forcing the SQL server to recreate the execution plan, right? So to find a new way, or to find again the optimal way to execute the query. So I'm just going to put this here. It's called option recompile. Obviously, do not use this on your production queries. This is just for test purposes. After this, I am going to turn on the SQL management server to include the actual execution plan, and I'm going to execute this query. Okay, so I've got 100 products out. This is the expected, the way I loaded the data. I'm expecting 100 products that never had any sales whatsoever. Let's take a look at the execution plan. Okay, now There are entire books written about how to interpret this, so I'm not going to go too deep into this, but some things do stand out, right? I don't see anything particularly wrong, so I don't see any table scans. This usually indicates that the SQL Server is reading the entire table before it does anything to it. But I do see these clustered index scans, particularly this one, this clustered index scan on the order line, okay? So if we look with some details over here, you can see that in order to find products that never been sold, it actually has to go through the entire index, clustered index, of the 40,000 rows that represent this table. This means that our query performance is tightly coupled with the size of this table, right? So if this table tomorrow is 4 million rows or 80 million rows, the performance will be proportional to the size of this table. And that's not good, right? What I really want to do is understand another way to do this query where I don't have to scan the entire table or the entire index in order to get what I want, okay? Now, the way I'm asking the question to the SQL Server, it's not that good, right? I am asking for the absence of information on a certain table, right? I'm asking, find me the products that do not exist, right? Find me the products that do not exist on the order line. And for that, it needs to go through the entire order line, right? In order to find out if something is missing. So that's why it is transversing or traversing completely the entire table and then grabbing the 400 products from here. It then joins them. It actually produces 40,100 rows, and then it does the filter to find the 100 products that I finally want, right? So is there a different way to write this query in the sense that I can get a more direct path to what I really want, which is missing products? And I have an example of how this query can actually be rewritten, okay? Let me just load it over here. So in this query is more or less the same, right? I'm still getting the ID, the departments, the product, the unit price, all good stuff. But instead of doing a left join, I'm doing a not exist, all right? Conceptually, this is exactly the same thing, right? But let's see what the execution plan tells us about this query. So let me execute the query, okay? And I'll look at the execution plan. Now, if you notice, the order line table is now just outputting 300 out of 400 rows, right? So if I select this over here, we can see that in total, 400 rows were scanned and 300 rows were outputted, right? So the output of this is not for 40,000 like it was before, it's just 300, okay? Now, why does this query work in a slightly different way? Because in the order line does have an index related with the foreign key of the product ID, right? So it's very easy for the SQL Server to understand from that index how many distinct products exist on that index, right? So it could immediately find the 300 lines that really matter for the query that I'm doing, right? The 300 product IDs that were sold during this period, right? And then it can easily then join with the 400 products that exist on the catalog, and then finally figure out that 100 products don't actually exist there, right? So as you can see, just by writing the query in a slightly different way, I am now binding the query to the products that exist on the catalog and the products that have not been sold, or better yet, the products that have been sold on the other order line, right? And I don't need to go through the entire order line table or the entire order line index in order to get that information. Okay, so now what I need to do, or what I can do, is copy this query and use it on my OutSystems project. Okay, so I'm going to copy the query. I'm going to go back to my Service Studio. I'm going to say convert this aggregate to SQL. Okay. And now all I need to do is, well, not just all, but now I can just paste the query over here. I will need to rewrite it a little bit because it is using the format from the SQL Server. And also, most important, is because it was converted from an aggregate, it put the entire tables over here. So it will get all the attributes from all the tables. And this is not what we want, right? So remember, always remember that SQL nodes do not have the optimization. So it's up to you to say exactly what you want to retrieve, okay? So I created this little structure over here with department ID, department name, product ID, product name, and unit price, which is exactly what I want. And in order to save you from writing the query, I already rewrite the query over here. So I'm just going to paste it from another file that I had here. So simple, select department, product ID, product name, unit price from product, da 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 da. Well, not exist, whatever. So let's click test. And as you can see, it executes perfectly well, right? So now what I need to do is just fix a few things. So my screen was actually pointing to the other aggregate. I just need to go here and say, well, I want this to point to the department. I want this to point to the product. There we go. And finally, the last one, I want this to point to the unit price. There we go. Okay. I don't need to do anything on the table itself, because when I convert it from the aggregate, the thing just worked fine. Okay. So in summary, this is to illustrate that even then when we have a simple, straightforward aggregate, right, it is worth take a deeper look into it and really understand what the SQL Server is doing, and maybe you need to rewrite it on a different way so that you won't have any performance issues later in your project. Okay, so the other thing that I want to talk to you about is related with indexes. So when you start having performance issues with your database, creating more indexes from the ones that come by default or are created by default with the platform is a nice way to speed up things, right? To make your queries more efficient. However, this is not an intuitive process. Okay, you really need to go into the SQL Server, right, or the Oracle Server, and understand what is going behind the scenes. So let's first take a look at the indexes that the platform creates. So if I select a table, right, or an entity, and I take a look at the indexes, you will see that some indexes are automatically created by the platform, right? So everything that represents a foreign key into another table, the platform will automatically create these indexes. Now, these indexes are useful for the joins, essentially, right? Or for a lookup based on the index, but not necessarily to do other types of queries. Of course, the platform will always create a clustered index on the primary key, right? So there will always be, for each table, an associated index with the primary key. All right. So the next example that I have is this little query over here, okay? And what is this query trying to do? This query is trying to understand sales in bulk. I called it sales in bulk. And the idea is I want to identify which products have order lines above a certain quantity, okay? So if we take a look at the query itself, we see that I have the product that only have sales, so only with inner join order line, and then an order line inner join with the order. And on the filter, I have where the quantity of an order is greater or equal than something, all right? Okay, so now let's take a look at the query on the SQL Management Tool. So let's open the SQL Management Tool. Now, I already have the query ready, so let me just load it, okay? So this query, because it has a parameter, I have to declare the parameter and set the parameter to whatever value I want. And I also added this option recompile again to make sense out of the optimizer. Okay, so let me select the optimizer and click F5, and let's take a look at the execution plan. So again, I am asking for products above a certain quantity. Okay, so looking at this execution plan, and my biggest concern is obviously the biggest table, the order line, we can see that it did scan the 40,000 entries, right, to return only 384, which makes sense, right, because it's looking for quantities which are on the order lines above 384, okay? So you might be thinking, all right, this is interesting. What if I create an index that targets the quantity? Maybe it will immediately find the ones that have more than, in this case, 990. Okay, so let's go back to our Service Studio. We are going to the order line and let's add a new index. Okay, I'm just going to call it index 1. It's not a unique index, and I'm going to say put the quantity in the index, right? So it should be able to find immediately the order lines that have this quantity. So let's close this, let's publish. And you know, there's a new feature in Service Studio that if I stay really quiet, it will publish really, really fast. Let's try it. And what do you know? It actually works. I love this new feature. Okay, so let's go back to our SQL Management Studio, execute the query and see if there is any difference. Oh, by the way, don't forget to put the option recompile when you're doing these types of tests, okay? And we see that absolutely nothing changed, right? So it's still scanning the 40,000 rows and it's returning the 384. But why is it still scanning the 40,000 rows? I just gave it an index that would, in theory, make it able to recognize immediately which rows are above a quantity of 9,900. Right? So something is off. And the reason for this is that although it has an index that is targeting the attribute that I want to search for, in order to get the rest of the information, right, in order to get the order and later the products and so on, it would have to jump around, right? And SQL Server can only use one index in one operation, okay? So there's no way that on the same operation it will be able to use two indexes. So when it looks at the statistics, when it looks at whatever is available for it to help solve this query, it's going to say, I don't care about that index. I will just use the clustered one because I will lose more time going back and forth trying to figure out what to do with it than to just scan the clustered index and have all the information that I have. Okay, and this is why you always need to use this type of tool to understand the execution of the query, to understand how the database server processes the query in order to decide what indexes to create. Okay, all right, so now we can go back to Service Studio, go back to the indexes and refine this index a little bit more, okay? So it wants to join the quantity, right? It wants to join the order line with the products and the orders, right? So let's add a few more things into this so that it gets all the information it needs at the same time by reading one single index, right? So here I am going to add the product ID, okay? And then I am going to add the order ID, okay? I'm going to close and I'm going to publish. And let's see if it works again. Wow, this is amazing. I got to send an email to engineering congratulating them on this new feature. Okay, and now let's take a look and see if our query execution behaves any different, right? So press F5 to execute, and now we have some differences, right? I now have a seek index, and if we take a look here, it was able to identify exactly the 384 rows that interest me, okay? So sometimes adding a little bit more information to the index allows the query to be resolved on a different way. It is not clear a lot of the times where you think, oh, I'm just going to add this attribute to the index. It's not immediate. You really have to use this type of tool and understand the process behind the query optimizer, right? so that you understand, will it use my index? Is my index useful or not? Now, the last thing that I want to mention to you is about modern SQL, okay? Most of us learn and still use what can be described as ANSI SQL 92. The standard language of SQL created by the Standard Institute came out back in 92, right? 1992. In 1992, we were all using Windows 3.1 or 3.11. Do you remember Windows 3.11? Probably not, okay? Now, this does not mean that SQL hasn't evolved. The latest standard came out actually, I think it was 2011, right? And implemented a few new keywords that are very interesting to use. So if you are still using the basic standard from SQL 92, take a look at the new keywords, right? And I can point you to a couple of them that are very interesting, which is the with and which is the pivot, okay? I'm going to show you an example using the pivot because it's a kind of a less known or less used query statement, okay? Now, picture this use case. I want to show the 6 months of sales, right? And I want to show 6 months of sales by product, okay? And by month at the same time. So based on a reference date, I will put the dates over here, the last 6 months, and I will put the products over here, and I will accumulate or sum each one of the quantities so that I know how much each product sold each month, okay? Now, this sounds like a strange query, and it is, so let's take a look at how we would do this query, okay? So we would select the product ID, the product, and then we would sum, right, based on the condition, right? And over here, the only thing I'm doing is figuring out if it is the month 0, month -1, month -2, -3, and so on, and creating the sum buckets based on the date that exists on the order, okay? So from this point on, it's fairly straightforward. From order line, join with the order, that's where I get the date, and group by product ID and product. And this works fairly straightforward, right? So when I do test, I don't have the proper month labels because this is dynamic, right? But I can see, you know, products being sold in this month, the months before, and so on and so forth, okay? So let's take a look at this query inside SQL Management Studio, right? Over here, there we go, okay? So this is essentially the query that we're doing. We can even turn on the execution plan just out of curiosity. You see, right, it's accumulating the sales of each product on a column, and the column represents current month, previous, and so on and so forth. Now, the execution plan doesn't have anything particular to it, right? It's using the cluster index and so on and so forth. So not much to optimize here at this point, right? But this is a hard SQL this SQL is hard to write, right? It's very complicated. It's hard to maintain. But with the new pivot table, this makes a lot more sense. So if I show you this query rewritten with ANSI SQL 2011, right? This is much more clear, right? So I do have to declare the variables and so on and so forth because I imported the SQL directly from the platform. And the only thing you need to do is the first inner query, right? Essentially what I'm doing here is finding out the sales of the products by date, right? And then the only thing I need to do is use the pivot keyword and say, I want to pivot this table, summing the column sales, which is this column over here, right? And then saying pivot by what, and this is the what, right? I just called it column M0, M1, 2, 3, 4, 5, 6, and so on and so forth, right? So it will identify the columns to which it needs to group by dynamically, right? You see here M minus and then -0 for month, current month, -1, 2, and 3, and so on and so forth, right? So much more easy to understand, much more cleaner way, and with the same results. And you might be thinking, okay, this is kind of new. It's actually older than the platform, but will my SQL node support this type of thing? And of course it does, right? So if I go here, let me take this one out, disable this one, and enable this one, put it over here. You can see this is exactly the same query that I had before with the pivot table, okay? So always remember that within SQL nodes, you are talking almost directly, well, it is directly with the SQL server, but with almost no filters, right? So it will pretty much support whatever you want to do, right? So typically, if you can do it in SQL, right, in pure SQL, you can do it using the SQL node inside the platform. Okay, now let me show you how this query actually executes. I need to, this query is dependent on a reference date. So let's give it a reference date. Let's say 2021-02-01, just to test this, and let's test. And as you can see, the query just executed, right? So I've got my products, my departments, my products IDs, and the sum of these values grouped by month, all right? So you want to see this working, I need to do a couple more things. I've got these two wordings over here because I changed the query, right? So this one, it should try to refresh the past 6 months new query. And this one, it's pointing to the wrong query, of course. So I need to say, you know what, point to the past 6 months new query. Let's publish this and take a look. Okay, publication done. Here we go. Let's open this and see how this query actually works. Okay, so there we go. We've got the product, we got the sales group by month, right, and so on and so forth. And I can even navigate and dynamically change the months that I see, right? So what if this shown up as a requirement in your project, right? A lot of people will think, this is kind of hard to do, but as you can see with the new pivot, no big deal. Okay, folks, so these are the 3 things that I believe will make a difference to your skills in SQL, and obviously to your project. Let's summarize them. You may have even a simple aggregate that might not be behaving well now or in the future, right? So the way to go there is to understand how the server executes the query plan and figure out if there is a better way to resolve the query and get an increased performance out of it. The second thing is, although the platform by default creates primary key indexes and foreign key indexes, most of the time these are not sufficient. So you can create indexes or extra indexes inside the platform. But this is not trivial, okay? It is not, or at least it is not as intuitive as it's supposed to be, right? Again, you need to use the query plan to understand how your database server will be executing or resolving that query. Finally, don't be stuck in 1992. It's 2021, right? So there are a few extra keywords on the SQL language. So go out there, Google them, find them, and you'll see that you will be able to create queries using a more modern SQL that is either more efficient or even easier to understand or to design the queries or even to maintain them. All right, everyone, I hope you have enjoyed this video. If you did, do press like, do press subscribe, and don't forget the notifications button. All right, well, you know what you should really do besides all of this? You should point the default page of your browser to this channel. That would be really cool. So everyone, cheers for now, and keep building those apps and use SQL. Cheers.